Hello, you're welcome to this lesson. In this video, we are going to learn about what random variables. Okay, so let's look at what random variables are. So a random variable is a function that assigns a real number to each outcome in the sample space of an experiment. Okay, that's a random experiment. So it assigns a real number to each outcome in the sample space of a random experiment. So let's look at what that means. So let's say we are conducting a random experiment which involves tossing two coins. Okay, here are the possible outcomes that we can get from that experiment. You can get a head head, we can get a head tail, we can get a tail head, then you can get what? A tail tail. Alright, so these are the possible outcomes that you can get after tossing two coins. Okay, so let's look at how you are going to get our random variables here. So before you can get our random variables, we will have to define our random variables. Okay, and then represent random variables with what? Capital X. Okay, so let's say our random variable equals what? The number of heads. The number of heads in each outcome. Okay, the number of heads. Okay, so our X is the number of heads, right? So if you look at the first outcome, we are going to have two heads. For the second, we are going to have one head. For the third, you are going to have one head, and then for the fourth outcome, you are going to have what? Zero heads. Okay, so from here, you will see that our x can be what? Any of these values, which is 0 up to what? 2. X can be any of the what? These values. Okay, so we see that what? X is what? A random variable because it can take either 0, it can take either 1 or 2 after what? The experiment. It is not specified. So x can have any of these values 0, 1, and 2. Okay, this is what this means. Okay, so there may be a situations where you see something like capital X equals what? Small x. Okay, what this means is that the small x are the values in the bracket, okay, which are the possible values that what the capital X can what have. Okay, so if the number of heads is equal to 0, then that means that what our capital X is equal to what? 0, right? And then if the number of heads is equal to 1, then capital X is equal to what? Capital X is equal to 1, and then if the number of heads are 2, then capital X will be equal to what? 2. So the small x are the possible values that what the capital X can what have. Okay, this is what it means. So this is what a random variable is. Okay, it assigns your number to each outcome in the sample space of a random experiment. Okay, and then there are two types of random variables, which are the continuous random variable and then the discrete random variable. Okay, continuous random variable and then discrete. We're going to look at the difference between these two. Okay, let's look at that. Okay, so normally continuous random variables can take any values within an interval. Okay, can take any value within an interval. Can take any value. Okay, and then the discrete random variables take specific values. Okay, they take only specific values within an interval. Only specific values. Okay, so let's look at what this means. So let's say we are considering numbers between 1 and 2. Okay, we are considering numbers between 1 and 2. Okay, so let's look at the continuous side. So considering numbers between 1 and 2, okay, if I say I'm considering numbers between 1 and 2, I can have a wide range of what values there, right? I can have 1.01, right? I can have 1.0001. I can have 1.001, okay, 2, 3, and so on. You see, I can have a lot of values within this range. Okay, and then what will happen is that you can't even count the values individually, because even if I'm considering this 1.01, okay, it can continue. You can have 1.011111 and so on. You can't finish counting this value. Do you see it? So in this case, we consider this to be what? A continuous we'll consider these values to be what? Continuous or random variables. Okay, so what will happen is that for the continuous random variables, you can get any value at all. Okay, and then some of the values will be very, very, very close. You can't even see the difference between them. Okay, some of the values can be what, very, very, very close. That's what the continuous random variable is. Okay, so for the continuous random variables, we don't really deal with intervals. We don't deal with what, intervals. The values can take any value at all. Okay, but for the discrete, we consider only specific values. Okay, so between 1 and 2, for the discrete, we can have values like 1.2, 1.4, 1.6, 1.8. Okay, that's between 1 and 2. So if you look at these values here, I can count 1.2, like 1.2 is 1.2. Okay, 1.42 is what, 1.4. There are no other decimal that's are part of it that I can't count. I can't count all. You see, just like unlike what I have here. Okay, because you have 1.001, it can continue. Okay, but for this we just have 1.2, we just have 1.4. Okay, the values are specific values. Okay, so one thing you have to know about the discrete random variables is that we consider gaps between the values. Okay, and then these gaps should be able to make what, the values very, very what, distinct. Okay, you should be able to what, make the values what, distinct and then different from what, each other. That's what discrete random variables are. Do you see it? The values are very, very distinct, unlike the continuous random variables that there may be a case where you cannot see the difference between any two of them. Okay, so let's say we are counting the number of cars at a particular car park. Okay, but we don't know the number of cars that are going to be there, right? So we know that we don't know the number of cars that are going to be there, but we know the range of the number of possible cars that we can have at that car park. Okay, so let's say you have a car park that can take, let's say, up to 20 cars. Okay, so up to that 20 cars, we can have 2 cars, you can have 4 cars, you can have 10 cars, you can have 15 cars, you can have 18, we can have what, 19, right? And then you can have what, 20. Okay, so you can have at a particular time, we can count any of what, you can count the cars to be what, any of what, these numbers, right? And then you see that these are just specific values, right? 2 is very different from 4, 10 is different from 4. All the values are very, very distinct, and then we can count each of the values what, individually, right? So this is what, a discrete sample space. Okay, this is what, a discrete sample space, because you can count the values, right? And then the values are very, very distinct. But let's say we are measuring the weight of people. Okay, and then we are measuring the weight of people, and then let's say on average, you know that the weight of the people are going to be between 50 and then 60. Do you get it? In this case, you can measure someone's weight, okay, and they are going to get 50.1001. You can measure someone two's weight, and they are going to get 50.100, okay, 002. Do you see? And even between this 100 and then 1002, you can get people whose weight will fall within what, this range. Do you see? So you see that for the continuous random variable, we can get any value at all. We don't deal with what, we don't deal with specific values. Okay, you can't say that the weight of people are going to take specific values. No matter what, there are going to be difference between the weight of what, people. Okay, so in this case, we consider measuring the weight of people as what, random continuous what, random variables, and then counting the number of cars at a particular car park will take what, discrete what, random variables, because those values are going to be what, specific values. You can't say that you went and counted the cars and then there are 2.5 cars there, there are 2.566 cars there. You see, they take on specific value. And then what you have to know is that for the discrete random variables, they are obtained through counting. Okay, they are obtained through what, counting. They obtain what, through counting. And then for the continuous random variables, they are obtained through what, measurement. Okay, measurement. And you know, we measure weight, we measure time, we measure temperature. Okay, so those are if you conduct an experiment that involves measuring the height of people, that means you have to know that the possible random values that you are going to get are going to be continuous, right? Because there are some of the values that are going to be very, very close, right? You can't tell. Okay, you can have someone's height to be 1.41 inches, you can have someone's height to be 1.40, or other values very, very close to these two values. Do you see? So you can't really tell. Okay, so the height of people during an experiment can take any value at all within the specified interval that you have. But if you are looking at counting the number of cars, it can only take on specific values. There can be only one car, there can be two cars, there can be four cars, but you can't say there are 2.5 cars. Do you see it? But that doesn't mean that discrete random variables cannot be in decimal form. Okay, they can be in decimal form, but you have to know that they do it what intervals. Okay, we consider what intervals. Okay, let's take note of that.